let us start in understanding about the Glacier Lake outburst floods. So, what is this is all about? So, what happens is we already know due to climate change, glaciers are retreated, and the retreating glaciers can lead to the formation of moraine dam lakes, and which they can burst and they can cause outburst flood due to failure of the dam. Uh, this can significantly affect human life and infrastructure downstream. So, if you really want to study this phenomena, then first we need to identification of potential lake sites. We have to predict the expansion of existing lake. We also need to understand how much is existing lake, its volume, and numerous other aspects on this. So we will cover those aspects of today. So the first we need to understand what is the origin of these lakes. So these lakes are caused because of the various reasons, and in addition to the glacial process, but this is one of the important aspect of origin of glaciers, where initially glaciers are excessively covered by the debris, and the debris uh, will lead to the formation of small ponds on the glaciers. Eventually, these ponds become bigger, and it leads to the formation of huge lake on the glacier, provided underground topography allows it to happen. If it is not allowing it to happen, then it can drain out over a period of time. So there is also important facets of geomorphology into this. If glaciers are large and they are creating outwash plain and the region is plain, then it is quite possible there will be numerous streams and glaciers and water will flow either into the river or into the ocean, wherever it is going. But topography is highly undulating, and then there are a lot of moraines on it. So it is quite possible that this can obstruct and create the moraine dam lake. But what is really a key region why there is the lakes are formed, particularly into the Himalayan region, or that matter, all mountain region, is over deepening of bed, and that is because of the glacial erosion. So we have already seen that glaciers have a head wall, then they have a glacial ice. This is a glacial ice. So So this is a glacial ice. This is up to this particular point is glacier ice. So we know now that when the glaciers is flowing, glacier flow direction is not parallel to the surface, but it is some region it is vertically down, submerging velocity, and some places which is the emerging velocity. So what really happens is some amount of rock which is picked up from the head wall, they go into the glacial ice and they go at the bottom of glacial ice and keep on moving along with the glacial flow, creating the erosion of wall and creating a depression. So what is really once they continue to flow, and then ice will come up, and then eventually that rocks are dumped here as a moraine, and these moraines are known as terminal moraine. So what happens is once glacier is retreated, then this forms this depression can lead to the formation of a lake. So that is how the lake is formed. So this amount of water can store, and if this whatever terminal moraine created. If it has ice at the base or if it is temporary in nature, then it can lead to the flash flood into the Himalaya. And there are numerous such massive lakes in Nepal. You can see here, this is massive terminal moraine. So you can see this is a natural dam formed due to the terminal moraine, and this is glacier have retreated, and this is a glacial lake, and this is a snout of glacier, and this is a glacial ice. So glacial is flowing like this. So this kind of huge lakes can form, and they are being studied in Nepal. You can also look this on satellite images, and you can see how huge these lakes are. So this is one Taso glacial range in Nepal, and you can see that this is fairly old picture, but you can see how large lakes can be formed due to the retreating glacier. This also influences the amount of retreat of glacier, but it also creates the risk for the people who are living into the downstream. You can see the another Tungi Glacier lake in Nepal, and you can also see it is very large, and some moraine over here is obstructing this flow and creating huge lake near there. So you can see here, the thickness must be very large because it is showing mountains, it is showing shadow over here, suggesting that huge thickness of the glacier. So this is another lake in Nepal. You can see there are numerous. So we have looked into this phenomena, why glaciers are retreating, why lakes are forming. We have discussed this issue quite in depth previously. But how it gets triggered? There could be various reasons why these lakes can burst, and there are numerous reasons. First reason could be because of the heavy cloud burst. So if this region experiences large amount of precipitation, it is quite possible these lakes can burst. It is also possible that if there are depressions surrounding this region, the loose moraine can fall and create a small temporary lake, and it can cause the outburst. That is precisely has happened Uttarakhand a couple of years back. Then there could be a snow avalanches. That means if there is a sudden avalanche is taking place into the glacial lake, then it can temporarily increase its size and topple the dam. And there could be landslide, or there could be melting of moraine. What it really understand is this particular moraine over here is a rock on the surface, but below its core is filled with ice. So over a period of time, that ice is slowly going to melt, and it can lower the thickness, height of this dam, and it can burst. So there could be that, or there could be earthquake, which can lead towards the outburst of this. So when it comes to the Himalayas, we have a lot of glacier lakes, and this is one of the old. You can use the satellite images to do that, and probably you have done the exercise on NDSI. Likewise, if you use the band between the green, and if you use the near infrared, you can develop the water index, and by using automatic water index and satellite images, you can map the glacier lakes. So there are a large number of glacier lakes in Himalaya. This is a very old data, but subsequently we will go through it and try to understand how these lakes are, how many lakes are there throughout the Himalayas and this thing. So this is one distribution in Alaknanda Basin. You can see that this is very recent work, which is the last year is only published. And you can see that there are a large number of lakes in Alaknanda basins, and they are distributed everywhere. And what is also plotted here is hydropower dams. So you can see hydropower dams, and you must be wondering where is in Alaknanda basin. where is the region which has experienced flash flood. So this is probably Rishiganga river, and this is this one or this one, somewhere is the Rishiganga river, and it has caused the flash flood. Uh, so we will visit that issue tomorrow in depth. So this is also there. There are also large lakes in Sikkim. So you can see here in Sikkim there are more than 100 the more than 100 glacial lakes are there. In Sikkim, Himalaya, 56 are very high altitude, some are middle altitude, and some are very low altitude. So this is a major issue into the eastern Himalayas. We already know there are large lakes in Nepal, there are large number of lakes in Sikkim, and there are large number of lakes in Bhutan. So all these regions have very huge lakes. You can also use the remote sensing technique to find out how lakes is expanding with time. We are fortunate to have satellite images way back in 1970s when the first satellite data was available from MSS or other sources, and you can see how since then this Gipangat Glacier in Himachal Pradesh, how this is expanding. In 1976, it was just 27 hectares, and 2001, 55 hectares, and it is expanded much bigger than this right now. So it is expanding very fast. So how do we do that? Because by using satellite images, we know that it is possible for us to delineate lakes in high altitude region. However, it is not necessary that all lakes can be a potential source of flash flood. Therefore, first we should see if glaciers are associated with the glacial terminus, then potentially it can create a hazard. We should also study the lake. Is it expanding continuously throughout last 30 years or 10 years, 20 years, for whatever when this was formed? If it is expanding continuously, then it is unstable, and we can study it further. So essentially, we should apply this threshold to identify lakes from where we want to undertake the further investigation. So key question is, what are those further investigations? So we will, and one of those further investigation, it starts with understanding Himalayan thickness map. You can do this is I think you are going to have a very detailed presentation on HIM theme, and maybe you will see the demonstration of this mapper. This particular tool was developed here at the Devecha Center, and it is now extensively used to understand the glacial thickness. It gives you glacial thickness. You have estimated glacial thickness by using laminar flow method previously, and same idea is embedded into this tool, so you can do it automatically. It can give a glacier volume, and it can give the future expansion of glacial lake. It is not that only, it can also give that where the new lakes will be formed in future, this you can do. So this is one of the output from then Parvati Valley, and you can see here is that, 1 minute, something. Okay, so this is output from there. So you can get, by using HIMTHINK tool, a glacial thickness. Then you can understand future extent of lake and potential lake volume. So all these parameters you can use by using HIM tool, where we can also identify potential lakes also. That is, this is the Samudra Tapu Glacier. You can see where these new lakes likely to form in future. You can do it. But this is one of the key ideas. But key question to you is how much, because we already know that remote sensing can uh, provide you aerial extent of lake, because that is very easily we can see by using satellite images, because here you can see that here you can see that this is a water body which can be easily identified satellite images, and you can, some of that can be easily marked on the satellite images. But what we do not know is its depth. How much is the volume of water is stored in this? This is where this technique is very unique. Essentially, because what you can do in this technique, you can take the historical data. That means you can take year 2000 data, and from there you can estimate the depth of glaciers, and you can bed elevation, and you can get how much is the volume of this over deepening, and then you can, certain amount of interpolation will able to give you how much is the further expansion, how much will be lake volume. So you can estimate the lake volume by using this technique as well. Because once you have a volume, you also need to go into the field to understand how much is really on the ground, because whatever you are getting is only from model, even though it is verified, but it is on, but its only aerial extent is verified, its depth is not verified. Therefore, there are numerous available, like radio echo sounder is a technique by which you can go into the field and you can collect the depth information of the glacier. So this one was done particularly in a hazard assessment done in South Lona Glacier, where people have gone into the field, particularly on boat. You can see here, these are all water bodies, these are ice which is floating, and people have gone and collected the depth. So depth can be estimated using field investigation, using sonar technique. It is very time consuming because physically you need to go there and do this investigation. But key question is, it is not only depth which will help you to assess the how much is risk from these lakes. There are so many other investigation you need to do that. One of these investigation is geomorphological investigation needs to be carried out of the basin, because we need to understand how much is the snow and ice avalanches are likely to take, is there potential for landslide, and it can trigger a flash flood. This is an important idea, essentially because good geomorphological investigation is necessary to assess the potential source of flash flood. So in order to do that, you can do it 3D. People have gone into the field, and you can see here, this is a South Lona Lake, and this is a one moraine ridge, and this is the main glacier. This is the main bedrock ridge. You can see there is a gap between that. So people have concluded after having detailed investigation that this has no potential for avalanches or landslide, because this is a small area which is between the water and top of the ridge, but in between there is a gap over here, and that gap, if there is a huge avalanches or landslide takes place, it will not reach the water. However, you can also see that there is another lake over here, and that is also contributing water into this. So we need to understand what happens to this lake also. So, so that could be a cascading effect from one glacier lake to another glacial lake. So it is very important for us to understand the geomorphology of the region to assess its potential. In addition to that, we need to understand resistivity survey to map ice cover below the moraine ridge. So this is a moraine ridge of South Lena Glacier, and resistivity survey was carried on that. What is the purpose of resistivity survey? Is to understand the extent of ice below the moraine. That means if it has a huge moraine, huge ice below that, and what is the thickness of top layer, thickness of this debris cover. Essentially because it provides you some option on mitigation. Suppose you have a huge ice mass which is just below the surface, then you may not be able to expand this particular channel, or can we increase the depth of this channel? It depends upon the position of ice below the moraine. You don't want to go till the ice moraine and then expose the land, and then the ice moraine will start melting, and eventually it is causing a catastrophic flood. So avoid that. We need to understand how much we can really expand or deepen this channel, which is very important for them. So we also need to understand whether this is really a problematic or not. And for that, what you need to do is to run the hydrodynamic model to understand the flood potential. So these are some models which are now freely available. You can download it and you can work on it. So these models are based upon shallow water wave approximation equation, which is similar to the shallow ice approximation which we have used in estimation of depth. It is identical for that. And it requires input parameters like topography, bathymetry, frictional resistance, initial value of water level, boundary condition, rainfall, and stream flow. So the model, once you set up this model and you run this model, the model can provide information of river stage, time taken to travel flash flood from place of origin to nearest human settlement of infrastructure, and it can also simulate the different condition of rainfall. What it means that you don't know when this flash flood is going to take place. If flash flood is going to take place when there is a cloud burst, then soil is already at field condition and river stage is already very high, and this can cause a catastrophic flood. If it is going to take place in the middle of winter, like what we have in Uttarakhand, then it is quite possible that if there is ice avalanche into it, or whether there is a snow avalanches into water body and it bursts, then it is a different flash flood is going to take and different time it is going to take. So if we really feel that this lake has a large, if this lake has a large potential to significantly influence the human settlement down, then we require to address these by mitigation. So this is one work you can see where the risk assessment was carried out by doing systematic work, and this work is in Safed Lake, which is in Uttarakhand, and you can see how much is depth, if this Safed Lake burst, how much is a depth of flash flood will be there. So at some places it will be up to 4 meters, some places it is much higher, some places it is higher and then it is lower. It can also tell you how much is the velocity this is going, water flow is going to have. Some places it is depending upon topography and the distance from the flash flood. This could be from velocity from 0 to 5, 5 to 10, or it is very high in some places, 15 to 20 meter per second. You can also do this. This is, I hope it will run. Will it run? I don't know. So this is a video which is, 1 minute. Let me see if I can do in this mode. Yeah. Can you see it now? At least something you can see.
Yes, sir. Yes, sir.
No, it has again gone. So I will show you now. So this, if this is a South Lonak flood, if it bursts, it is showing the propagation of flood wave, and you can see how it is expanding. So this work was done at the Vecha Center, at our center, where we have used the ANUVA model to simulate this flash flood. So how much it will cause? We can also do it how much, because this is South Lonak Lake and this is the Changtung, the first human settlement. But of course, in between, there are crucial establishments are there. It is not, there is a road which goes to the border region. So in that sense, it is very crucial. So you can see that how much depth it can give is around, it is varying from maximum up to 9 meters of flash flood it can give. So maybe we can go back to previous slide and look what it is giving you is how much is it is taking the amount of time, and this different color codes tell you how much is the depth of flash flood. It is varying from place to place depending upon the topography. So we know now how long this is going to take to come to Chongtang, how much will be flash flood. However, we do not know yet by using this model in between if there is any addition, if there is any landslide, if it does along this way, what kind of impact we have. But we already know now that there will be a catastrophic flood. If this breaks, then nearest town affected will be Chungtang, and it will take 3.5 hours once this flash flood breaks. So it will take 3.5 hours to arrive at Chungtang, and it has a maximum inundation of 9 meters it can have. So we know one thing for sure: this 9 meter is a fairly large rise in the water stage, so it can have a catastrophic flood and significantly affect the human settlement. But one good thing about this is it has 3. Take almost 3.5 hours to take. So if we have an early warning system at South Lona Glacier, then we can warn Chungtang 3.5 hours earlier, and we can definitely save the human life. So this is really ideal textbook case for having early warning system. So we can have early warning system over here where the sudden increase breakdown, we can either you can have inside the lake where sudden the decrease, or you can have on the river where sudden increase in river stage can give you early warning system. So this is we can do it, but also we can do certain amount of mitigation, even though I have talking about, but you can also do the mitigation. What it means is that we can expand. If you can look here, we can expand this this channel. And one of the advantage, even though I tell you this, when we do the resistivity survey, we realize there is a huge ice which is below the moraine, but we have a significant thickness of moraine above that. So we have capacity to actually drain at least 5 to 10% of water from the lake by expanding its channel, but it doesn't have that much capacity. We cannot go beyond that. So some of those ideas was to use by siphoning technique. But what really happened in siphoning technique is the amount of water withdrawn was not very large. And there was no hydrological calculation subsequently was carried out when this early warning system was really installed. So it has not able to significantly reduce the thickness or the level of water. But this is a siphoning technique, is one technique which can definitely use, provided we know how much is the inflow of water into this lake. And inflow could be from various sources. Either inflow is coming from glacier itself, or there could be adjacent glacier contributing water into this. So this is a complex hydrological analysis we need to know, and then we should realize how much water we need actually to siphon out to reduce the depth of glacier or volume of lake. And it can change quite dramatically, essentially, because if there's a heavy rain, then inflow could be very high, and we may not be able to reduce it. So there are a couple of ideas one can try and see under what condition it will succeed, under what condition it will fail. But early warning is a definitely idea which can succeed, provided there's a sufficient distance between the flash flood and the site. You remember that Uttarakhand doesn't have that much distance. All these things happen within a 5-6 kilometer in length, and because of that, even if we had early warning system, we may not be able to, because it has not taken long time, maybe 10-15 minutes time to come the flash flood. So, and this phenomena was completely different, and we will really discuss this issue tomorrow in different way to say that how early warning system would have helped and how it would might not have helped. So we will discuss all these issues tomorrow.